So you have come here to see some practice questions for doing trig on right triangles. So basically, trig using right triangle, that means that you're going to be using SOHCAHTOA. You probably learned it. And I don't know if it's only me, but when I hear this term, I think of Pocahontas.
Okay.
I don't even think about right triangles. I just think of Pocahontas. I don't know. It seems like a Native American word. SOHCAHTOA. I don't know. I think I'm being racist here. In this video, we're just gonna focus on SOHCAHTOA, using SOHCAHTOA to solve the missing side or angle with these right triangles. So here's the first example. We have here that we have to solve for this missing angle right here. And if you don't know, that just means theta. And it's like kind of a way to fill in like a missing term, I think. So if we point an arrow, we see that this side is the opposite side, this side is the adjacent side, and this side right here, the long side, is the hypotenuse. Right away you can tell the hypotenuse would be the side across from the right triangle because it's supposed to be the longest side. In a right triangle, if one side is 90, then that means it's going to be the longest side because another side can't be greater than 90. And so here we're given adjacent and hypotenuse, so then that means we're going to be using co here, which is cosine. And so that means that cosine theta equals 12 over 13. And when we put that in the calculator, it should look something like this. We use that negative sign, and then we just put in the fraction there. And then like that would give us the answer. But make sure that you have your calculator on degrees, unless it would give you a different answer if you have it on radians. So make sure it's on degrees. If you're using a real handheld calculator, I'll probably post a video on that later. But for now, yeah, I don't. It should be like shift, or just shift cosine, and then it will give you the negative one if you're using a graphic calculator. Scientific calculator, I don't think you can do it. But yeah, and then so this should give you the answer 22.6 degrees. So that's the answer. Here's our next problem here. We're trying to solve for x, and this time it's x, not theta. It doesn't really matter, but you just know that you're solving for that. So here we have this and this, so let's see what the sides are. So this side is the opposite side, and this side is the adjacent side. So this is the hypotenuse. So that means we're going to be using TOA of SOHCAHTOA. That means we're using tan. So that means tan x is equal to 11.9 over 10. So yeah, and you put that in the calculator, see what it should give us. So if we have tan to the power of -1 in parentheses 11.9 divided by 10 should give us 49.95, which rounds it 49.95, which rounds it to 50 degrees. So we're gonna assume that we would round to the nearest tenth in these kinds of problems. If it probably doesn't say anything, just round it to the nearest tenth is what I usually do. So yeah, that's what x equals 50 degrees. Okay, so here's another problem. Here we are solving for x again, so let's see the sides. This one is opposite. This one's adjacent. We're not given adjacent though, so we're gonna ignore the adjacent. And as you can see, which one of the following trig functions doesn't have adjacent? It's sine. So the so part of SOHCAHTOA. So we're going to be using that. So it's sine x is equal to 24 over 29. Opposite over hypotenuse. And so we put that into the calculator. Sines and -1, parentheses 24 divided by 29. And it should give us 55.85. And that would round to 55.9 degrees. So that's what you should get. Alright, so this is our next problem. It might be a little blurry because I took the photo from somewhere else. So let's read it. An escalator at a shopping center is 200 feet and 9 inches long and rises at an angle of 15 degrees. What is the vertical rise of an escalator? Round to the nearest inch. So from reading from this, when we're giving a word problem for trig questions, while we're reading it, before we read it, we probably just want to like draw a triangle here. And then it gives us some measurements. So 200, an escalator at a shopping center is 200 feet long. So we know this is 200 feet and 9 inches here. But it says we want our answers to be rounded to the nearest inch. We're going to convert 200 feet and 9 inches in 2 inches. So then here we can just do 200 times 12 because there's 12 inches in 1 feet. And that's going to give us 2,400. And then we can just add the 9 because we know that there's that 9 extra feet right there. And so this will be 2,409. And then it says, and rises at an angle of 15 degrees. So then that means that we know that the escalator rises up 15 degrees. So let's say we have a ramp and we raise it 15 degrees. We raised it by 15 degrees right here. So that means that right here is 15 degrees. And so now it's asking, what is the vertical rise of the escalator? So that means we want to know this length right here. We want to know how high the escalator went. So that's what we're going to solve for. And so I'm just going to place an X here because that's what we're going to solve for. So this right here, this word problem, we're solving for a missing side. So we set it up by just first seeing what trig function we need. So this is opposite, this is hypotenuse, this is adjacent. Looks like we're going to be using sine. And instead of putting x, because we're not solving for an angle anymore, we're solving for a side, we're going to put the angle next to the function. When we were solving for the missing angle, we would put the missing angle there. So whatever is next to the trig function is always only an angle. And now we would make this equal the ratio of sine. So that is x over 2,409. And so that's easy. All we have to do is solve for x. So then that means we're just going to multiply each side by 2,409. And so in the calculator, all you have to put is this. And then it will give you the answer. 623.5 inches. That should be our answer. I know doing that problem, we didn't really get to go into solving for missing sides, so let's just do one example here. So here we're given this angle measure right here is 37, and we have to solve for this x. So that's this is the hypotenuse and this is the adjacent side to 37. You always want to use the given angle the angle you're given. Or you could use this because all we have to do is subtract 90 and 37 from 180, and then it would give us this angle right here to use if you want to. But of course, that's just more work. And so here we're going to use cosine. So cosine 37 equals 11 over x. And here we have it at that x is at the bottom. And so you just need to remember that if x is at the bottom, not divide by 11. The function will be divided by the number. And make sure for here, make sure it's not like cosine 37 divided by 11. That's going to give you a complete different answer. We want 11 divided by cosine 37. That's what we want, and that would give us the answer. So if we do that there, cosine 37, 11, and that should give you 13.77 or 13.8. Now let's do one more example here where we're given a triangle and we have to solve for all of the missing things. So we have to solve for the entire triangle. That means that we're solving for this angle right here, this missing side here, and this missing side. Already off the bat, we can see that we can solve for this missing angle right here, because we know that all sides equal to 180, so let's just subtract. And that's going to give us 62. And so we can put 62 in here in red, meaning that that was one of our answers, and white was already given. And so we can use SOHCAHTOA here. We can use it for this angle or this angle, but let's use 28 here because it's given. So this is opposite, this is adjacent, and this is hypotenuse. So this side, or we could do this side, but let's label them. So I'm gonna label this X and this Y, so we know what side is which side. So we're gonna let's solve for X first. So that means X is opposite, and then this is adjacent. So that means we're gonna be using tangent. So tangent 28 equals X over 29.3. So we just multiply each side. That's going to give us, what is it going to give us today? 29.3 times tangent 28. And that's going to give us 15.57 or 15.6. So we're going to write this up here. X equals 15.6. We're just going to put Y equals whatever we get there. We're going to erase this work and put Y in it. And so for Y is the hypotenuse. So we could use X if we want, but I'm just going to stick with A again. So we have adjacent and hypotenuse. So that means we have cosine. So cosine 28 is equal to 29.3 over Y. So that means that we're going to divide. We're going to place the 29 over here, so the function can be divided by that. So that should give us 33.18 or 33.2. So Y equals 33.2. And then we have this right here, which is measure angle B. So measure angle B is equal to 62 degrees. So then that's our answer that we solved for each side of the triangle that was missing. So yeah, and that's your video on trig on right triangles. It gets more complex here. Next thing you're gonna learn is how to do it with triangles that are not right triangles, non-right triangles, obtuse triangles, or maybe acute. But yeah, and so yeah, that was probably the questions that you're most likely gonna encounter with right triangles.